Hi, I'm Jim W6LG, your ham radio Elmer. Welcome to my radio room here in Rockland, California. This is a video that's taken about 5 weeks to get it done, and the reason why I put so much effort into it is it's an interview with Shawn Billy Williams, ZS1SBW in South Africa, and we're talking about grounding and earthing, bonding, RF grounding. Um, Shawn and I discussed some things that you may not have heard before and may not have read anything about before. And in particular, Shawn brings up the importance of the ground rod and its connection to the earth and its resistance to the earth. But by way of explanation about the time frame, we originally recorded the video about 4 weeks ago, and I spent the next 2 to 3 weeks trying to edit it and to get it to look right, and it never did. The audio didn't line up, the video quality wasn't good, and no matter how I tried to maneuver it, massage it, it just didn't look good. So Shawn and I talk on the long path almost every day, and I asked him if I could do the interview again, and it's his year end with his business, but he agreed to do it. So we recorded the discussion again. That took about 2 hours. I've edited it down to about 35 minutes. And this time it looked pretty good. I had it all done except for the introduction. The hard drive failed in the computer because the power supply went nuts. So I had to get a new power supply and format the hard drive because it was just beyond recovery. And with that, I completely lost the edited video, so I had to start all over again. Fortunately, I had saved the original interview off of WebEx and a separate video of me with another camera and the audio yet on a separate track. So I have those three things that I could put together. So I've re-edited the video. Again, I put a lot of effort into it because it has some really important information. So here we go. After a lot of delays, it's Shawn Billy Williams, really nice guy, ZS1SBW, and we talk about grounding, bonding, earthing, RF grounding. Didn't really touch on lightning arresting because it's a whole separate can of worms. So here we go. ZS1SBW.
Yeah, you too. Whiskey 6 Lima Golf, ZS1SBW. Hello, Jim.
Hello, Shawn. I've been wanting to talk to you about the confusing issue for me for 58 years, and that's bonding, grounding, earthing, lightning arresting, and I don't know if there's another one, RF grounding, I guess. Did I mention that? So there's all of these things. You've done something that several things that I don't know of anybody else who's done that. So let's start with your system for grounding your station without worrying about it being AC or RF. Tell me how you grounded everything, because it really is different from everything I've seen.
Okay, so thank you, Jim. Always a pleasure talking to you on the long path, and then also on this
Yeah.
Optical fiber path is great as well, undersea cable path. Most amateur radio operators don't have the advantage of very high towers away from the station. Most of us have our towers close to the station with compromised height. Even I do. I don't have an ideal height, 65 foot. And some operators are they have end-fed half waves, as we Tesla coils, as we spoke about, and or balanced antennas. So there is a certain amount of RF that's induced into the station because of the proximity of the antenna. And the most important thing for me is the earth rod, the ground rod resistance. And the reason why I believe that's important is because Um, the entire earthing path is connected to your house or my house and to our neighbor's house. And if, for instance, if there isn't a ground rod, in some cases there isn't a good ground rod or a good ground resistance, and that's defined as 5 ohms for sensitive equipment radio stations. For the NEC or for the South African code or the British code, it's less than 25 ohms, as long as it's below 25 ohms. And for what we're doing, it's not good enough. So, just
can
yeah.
I just stop you there and kind of restate in a different way what you said? That no matter what code you look at, be it British or South African or the U.S. codes, and there's several in the U.S., they really are all kind of about the same. That the electrical system has to have a connection to the ground of 25 ohms or less, and in most cases, probably it's there. Now that 25 ohms is not you said ground rod resistance, and you don't mean that it's the resistance in the ground rod. You mean it's that coupling between that rod and dirt over a certain distance measured in a specific way, or
Yes.
with a specific device.
Yes.
And let's see, what was the other thing you said? And let me also say that as a former building inspector, for all of the times I inspected a house, which was thousands, I never measured that resistance. So again, ground rod resistance is the resistance to the dirt, let's say. Is that fair? So
Yes.
let's call it, maybe that's sort of earthing. And
Yeah.
then and that connects to the main panel.
Yes.
In your case, you'd call it a console.
Yeah, we call it the council panel, or the council supply board, or the council earth, and in your case, it'll be the main your main supply panel. The different terms, but the same thing.
Same thing,
So
yeah, same.
yeah.
The box may look a little bit different because of the way we connect, but it's basically the same. And the idea, the other thing that I want you to talk about briefly is what is that designed for? Is that designed for radio stations or for something else in the code when at that 25 ohm resistance they're talking about?
So the code doesn't take what we do into consideration. It's for appliances, stoves, hot water cylinders, washing machines, dishwashers, and all the household basic household appliances. And for that, it's good enough. And the reason why it's good enough, because all houses will have a residual earth leakage device, 20, and it will have a sensitivity less than 40 milliamps in most cases. And any of those devices will trip the residual leakage device. So the safety of the circuit for those types of devices and appliances is good enough. The earth path is not a fault path. The fault path is to neutral, because the earth would bond in the council panel in the council supply board, meter board. It would bond to the neutral, and so and it's essential, because you're not going to find it. You're not going to be able to trip a breaker to earth with a 25 ohm earth ground rod resistance.
So what you're saying is if we opened the cover and removed the interior cover on the console or the main panel, that we would find a ground bar and a neutral bar, and they're tied together at that point.
Yeah.
And they're those two tied together, and they go down to a common point in the US, a common point box. And then from that box, it goes to the ground rod. And in that common point box, the TV, gas line, water lines, they're all ground. They all come together as one ground. Also, as far as leakage goes, those still aren't in common use here. uh, uh, where it would trip at 45 milliamps
Uh,
or some, and that's a contribution that came from what country?
Yeah, that's a South African invention, and it's been a standard in South Africa for many years. And it saved a lot of lives. It's a good device to have. It can be annoying, and there are instances where you wouldn't use it. So, for instance, if you didn't want an earth leakage on your station, you could put an isolator close to your operating position, and you could bring in a circuit that's not on a residual earth leakage with an isolator within a meter and a half of your working position, and that would be legal, and you could do that. So there's a lot of ways to do it if you wanted to. But going back to your previous question about appliances, so for appliances and for household devices, the code's good. But for what we're doing, it doesn't make provision for what we're doing. And so there's this gray area, and this is a reason why nobody has a clear, kind of path to putting in the right earth installation for a station. We all do it in different ways. So obviously we want to compress this into the shortest possible time, Jim, so we can get the essential detail. So for someone like myself starting with my station, the first thing I would do is check the ground rod resistance. Now in South Africa, it's a legal requirement to have the ground rod resistance measured and certified by a wireman. So someone who has their wireman's license, that it's below 25 ohms. And you would have a certificate of competency, which if you purchase a house, you will have that with the purchase of the house, and then you would check it. So, but I wouldn't take that for granted, because earth rods change, ground rods change over time. Some are copper plated, and the copper evaporates, and you end up with a steel rod. I sent you some photos of some rods where the copper had evaporated within half a year.
I'll put one of those up on the screen now. Yeah.
I don't like copper. I won't use a copper plated steel rod. I use copper. I use copper water piping, class 2 water piping, for my earthing system. So I would. The first thing is to determine what that resistance is, and if the resistance is, let's say you're fortunate and you check it and you actually have a very low ground rod resistance. Let's say you have 5 ohms, which is the top. I would say the top limit for a radio station.
Yeah, let's restate that again, because as I said, it's never discussed, and it's probably the most important thing that anybody's going to hear in this conversation, and that is it starts at that ground rod. And if you don't have that right, a lot of other stuff doesn't matter. If you're just thinking about safety, period, it's a good idea. And we don't certify any of that stuff. So you're saying it starts for any amateur building a station, start with a ground rod, get a good connection to ground. Yeah. A driven copper pipe is a good way to do it. And there's lots of ways to drive it.
So the first step would be check what the ground rod resistance is, and then you would have to come up with a solution to bring it down to 5 ohms. And let me tell you why I believe that's important.
Okay.
So let's say so your station is connected, and I like the way that you do it with a copper pipe at the back of your desk, your operating position, and you bond everything onto this pipe, and then you take it to the common earth, let's say the earth which runs with the circuit back to the main panel to the console box. So okay, and if you take that approach, the reality is, though, your whole station is connected to the entire wiring system of your house. Okay, and if you are a newbie and you start out with an end-fed half wave, the other side of the circuit, which is the earth conductors that run with a twin and earth, we call it twin and earth, which is the same type of wiring that they use for plug sockets and outlets runs through the entire house, and you have a nice radial system,
Yeah.
which also doesn't stop at your console at the console box. It goes back onto the earthing system that goes to your neighbor. If your neighbor has a nice ground rod resistance, then his ground rod is going to be the ground rod for your station. So and so from an installation perspective, the first thing you want to do is make sure that your ground rod resistance is the best one in the neighborhood. And that none of your RF ends up on the earth that runs between, or even on the neutral, because it can also end up on the neutral, because the neutral's floating if your earth isn't bonded properly. If your earth isn't where it ties to the earth, where your neutral ties to the earth at the bonding point in the console box or the meter box, then the neutral becomes a reflector, a radiating a radial in your antenna system, depending on how you've got your station set up. So all of these conductors become part of the RF circuit, and that's the reason why that ground rod is where we should start, and make sure that
there is more than one reason. There's several reasons why that connection, which, as I said before, is almost never discussed, is missed by so many, and the consequences of that are all kinds of problems, and we can get into some
RF
of those.
Neighbor's house and
Neighbor's house, maybe RF on your microphone. In this subdivision that I live in, they wired intercoms in each of the rooms, and there's one at the front door, there's one at the back door, and guess what those are? They're audio amplifiers with wires connected. Those wires are not even a twisted pair, because I've gotten into the wall. It's just an antenna. So, if I don't have things right, I could be getting into my neighbor's intercom, even with it off. But anyway, so that you make a really, really important point.
And so there are exceptions to this, of course. We have if you have a station, let's say you have an installation like Mikey K6MYC, a good friend of ours. His tower is almost 100 foot. His hard line runs for about 800 foot away.
It's a long way.
And it's a balanced antenna, and his linear and his transceiver are coupled together with a feed line. He doesn't pay too much attention to his earthing system, because he earths to his socket outlet earth, which goes back to the main to the console earth. But his balanced antenna and his system is set up in such a way, and it's so far away from his station, it has a completely different, and we can't all have that.
And his feed line is buried, so it virtually is earth, because it's coupled to whether he likes it or not. He's got 800 feet of ground rod.
Yeah, and he's got no neighbors. His neighbors are miles away from him, and he's
been there, done that. Yeah, I know what that's like. Yeah,
but my neighbor's right next to me, and so they're all around. And so if I'm sharing their ground rod and their earthing system in their house, and it's coupled to my station, it's going to cause problems. So in my station, and going back to, I have 150 millimeter squared conductor, which is what I call my RF earth, my main RF earth. Everything bonds to that point. So I run individual earthing conductors to that point, from the linear, from the transceiver, and as home runs, as individual runs. So you can do it like you do it, with a pipe at the back or a copper bus bar, and you bond onto the bus bar or the copper pipe, and then that connects to a point. Mine connects to 150 millimeter squared, and that's a number 7 AWG7 conductor, which is 10 millimeters squared by 15 conductors. And the reason for that, again, is because of the skin effect. You want to make sure that you've got a lot of surface area You don't want one big thick conductor. You want a lot of surface area. And this goes outside my station to an auxiliary electrode in the ground.
Yeah.
That
Could you describe that? Because I don't know of anybody else. There probably is, but I don't know of anybody else who did what you did. So tell us about that, because it's different for sure.
So I have a earth rod resistance of 3 ohms, 3.1 ohms. Sometimes it's 2.9 ohms, depending on the weather. When in winter the resistance drops a little bit, but in summer it's around about 3 ohms or just a little bit, 3.1 ohms, somewhere there. That's the ground rod resistance that I have. So my station couples to an auxiliary earth electrode system about 1.5 meters outside my station. So as it goes through the wall, I have a core hole. I drilled a core drilled through the wall, and then I have that 150 millimeter squared conductor coupling to an earth rod. And then that earth rod is bonded with earth rods back to the council earth. So all bonded together.
Right.
And then from that earthing point, that I run conductors, 10 millimeter squared or AWG 7 conductors around the property, and terminate them at the ends with 6 meter earth rods, earth conductors at every end of those. And by doing that, I was able to get a broad distribution of earthing points into the ground, because we're on a sand dune here, and coupled to the earth to get the earth resistance down to the 3 ohms. It's not easy to get 3 ohms, so you have to invest.
It sounds like a hell of a lot of work. So
yeah, you have to invest.
You have buried wires in the ground, and they go and they terminate with another driven rod.
Yes, another driven rod.
Okay, so now do they fan out from a common point?
From this earth electrode that's outside of my station, which I call my RF earth. It's an auxiliary electrode, but I call it an RF earth, which is the main RF earth for the station. And they fan out from there. I use conductors, AWG 7 conductors which are coated like normal house wire. So it's not bare copper. And they run under the ground, and they terminate at random points around the property, so that I can get a broad distribution of.
That's interesting. So you intentionally picked different oddball lengths, because you didn't want something that was resonant, like, you wouldn't want them all to be, let's say, 20 meters long, or
no, you wouldn't want to. And as you would know, if this earth conductor, which goes to this RF earth that's in the ground, was a quarter wavelength, I would have some problems as well. So that's also something you need to take into consideration. You don't really want this conductor you don't want it to be a quarter. Look, it already would probably be too long, and that's why I've chosen the bottom floor, so as close to ground as possible. And I'm using class 2 water pipe for these earth electrodes, because you can wash them down with water, with a hose pipe. That's what I do. I wash them down into the ground where I am. I do that.
When you say wash them down, basically you're taking like a garden hose and connecting it to the pipe. Then you're using the water pressure to kind of auger your way into the soil. And because you're on a sand dune, it's in some places you may not be able to do that. But you might be able to get in the ground 3 or 4 feet, even in a tough place, or go on an angle, or maybe some other direction. So, so you've got a lot of copper in the ground then.
I have a lot of copper, and I started with it, and I've added over time. And when I got to my 3 ohms, that was where I stopped with it. And
was it a straight line in terms of resistance, or was it were the incremental changes always about the same, or did you really have to work at it to get it down to the 3 ohms?
When I started, I got to about 7 ohms. And then to get to that 3 ohms, it took a lot more effort. That was with the radial system, with earthing at the end of the radial system to bring it down. But we are between 3 oceans, so the Indian, Atlantic, and Southern. We're essentially floating here, as the water table is 1.5 meters down. We spoke about this before. So I am fortunate that I've got very good wet ground.
Your water table is down about 4.5, 5 feet. And
Yeah.
oh yeah, I was going to ask you, how did you know that was 3.5 ohms?
Well, this is I mean, I have one of these in my station, part of the station equipment that I have it, and there's different. This is a Uni T, and it's you clip it around the earth, the ground rod, and it gives you the resistance of the rod.
Do you drive another rod into the ground somewhere, or do you just clamp that on?
You connect the rod to your electrical system, and you couple it around the conductor that goes to the rod, and it calculates. It uses high frequency pulses, and it calculates the.
Okay. And I would think that, and I haven't checked, but I would guess that those devices are available for rental from a rental yard, because it's a fairly expensive device. And for a lot of guys, it's the price of a transceiver. So if you got the choice between that thing and a transceiver, you're going to buy the transceiver, but you could perhaps rent one of those. Or if you've got, you call them a wireman, we call them an electrician. You may have a friend, or you may be able to call an electrician who comes out, parks his truck out in front, goes over, measures it, because you really should have one. A decent electrician would measure it for you, and you're done.
All electricians would have one. A wireman's license is an electrician who's licensed to certify installations. So that's like a master electrician. They all have these devices. It's a standard device, because the old method is, you can't use it in buildings with concrete slabs, and this is a very suitable device for any building. You don't need to put in auxiliary electrodes around the property.
You drive a couple of rods a certain distance apart.
The old,
and put voltage between them, and read the resistance, the current flow, and the resistance. Go ahead.
So to make it easy for someone who's putting a station together, and going back to your thinking, where you use the earth that runs with the supply, the AC supply that supplies your station, if they do the work on the ground rod at the meter box, or the main supply panel, and they improve that rod by driving some other rods, and bonding them together, they can also achieve the same result. But it all starts with knowing what that resistance, that ground rod resistance is, and some guys probably won't even have
no. And you know what, you're right. And what I've seen it several times, where the gas company, natural gas, comes out, takes a measurement where they're connecting natural gas, and drive another rod, because they're not happy with the resistance, in particular, of the OOFR ground, which is a whole other issue.
And that's also in the NEC, and so not just the NEC, but this is what's called an auxiliary electrode. And there's a few ways around the code that you can get around the code for auxiliary electrodes. One of them is, there's a provision, it's a 250-54. I don't know if you know this. It's an auxiliary electrode. It's really a silly regulation, but exists. So, for example, if you have a lamp pole, they put a little electrode down. The electrode's meaningless, because it's not bonded back to it's not bonded to other earthing electrodes in the circuit. It's just sitting on the pole. And let's say if it's 25 ohms or above 25 ohms, it's not going to draw enough current. And if there's a fault, it'll just bleed into this electrode, and then you'll have some potential around the electrode, and it's potentially a hazard. But it's something that's in the NEC, which has never really been cleaned up. And when you work with the earthing electrodes, it's really critical that you bond them, you should never put an auxiliary electrode down and not bond that electrode back to the meter panel electrode or the console electrode. And when you do this, you need to take into consideration the length of the electrodes and the distance between them. It's actually the length of the electrode times 2 to the next. That's the actual ratio.
And let's talk about why, because it's obvious, but you didn't say it. You could have a difference in potential voltage.
Yes.
Between those two, and that could be a hazard. That could kill somebody. Or
if you've got, let's say, if you don't have a path to neutral on your station, and the earth goes hot, it's going to end up at that electrode, that auxiliary electrode. It's not going to trip a breaker because it's 4 amps or something, 110 volts.
On the neutral. Yep.
And if it's 220, it'll be 9 amps. It's still not going to trip the breaker or something around there.
And for those who think that can't happen, the house I bought, there was open ground, open neutral, reverse polarity. And as a building inspector, I inspected buildings, houses in particular, that burned to the ground or had a fire in a room because of something like that. So this is not just for the fun of it. This is crucial safety information. Make sure that you have a decent ground, period, whether or not it's for RF, but you just want to make sure that you've got, and that 5 ohms is a good target. Good target to be at.
And so the fault is via the neutral. The fault will always flow via the neutral. If the earth isn't bonded to the neutral, so if you have an auxiliary electrode and that isn't bonded back to the meter board or the console earth electrode, which is bonded to the neutral, you're going to have a hot electrode in the ground, and it's going to be at the potential of the supply voltage. And it's going to also have potential in a perimeter around it. So, a child could end up getting electrocuted.
Yeah. We didn't exactly say it, but in the past, I've talked about it being a 3-wire system. That's true inside some places, but really it's 4 wires. It is each side of neutral. So you got 2 hots, neutral, and a ground. Now, if you have elevated poles, electrical poles, you'll see a carrier and 2 cables wrapped around it. The carrier is the neutral and each side of neutral. But that's not the whole system. The other part of it is what you've said over and over and over again. It's the ground. And those are all crucial parts of the system. 25 ohms to me, when you think about what that would be with a substantial amount of current, just seems crazy high. I don't know why it's so high.
It isn't a practical value, but if you have a residual earth leakage on your socket outlets, for all socket outlets in your house, it's fine, because any leakage between, it depends on the device, if it's 25 milliamps or not more than 40 milliamps, but the residual leakage device would always trip for an earth fault. So it's 50 hertz or 60 hertz at supply voltage. So,
well, I'd like to finish with a brief discussion. And I'll try to show some pictures laid over this later, but basically at your radio station, which is different from a toaster or a water heater or any other thing, you want to have each box in your system that does something like a transceiver, a linear amplifier, an antenna tuner at the same potential above ground, or either ground or a little bit above. So it's best to run each one to I use a pipe we talked about earlier, but each one, instead of daisy chain, if you daisy chain them, this one may be 10 ohms, this one may be 8, this may be 6, this may be 4. Instead, run them all to that ground rod pipe. I don't want to call it a ground rod, pipe, and then that goes to your grounding system. And before we started, I mentioned to Shawn that I wasn't a big believer in RF grounds, but I'm getting religion as we do this. um, if you doubt that it's important, and have even if you're on the second floor, tie them to something and do the best you can. But if you take the cover off one of my amplifiers and you key it, stuff in this room goes nuts. Because
Yeah.
I've done that where I'm adjusting something because the RF is just going all over the place. Now, I did, and I'll try to show some pictures of this now. I did put up panels that have foil insulation. There's a copper strap that's separated from the foil, but it runs on top around the room. And I tied it all together, trying to keep RF in here. And to the point, and to the point, it works pretty well. I've got a clock on the wall that automatically checks, I guess it's with WWV or one of those things to update the time. It's still off by an hour because it can't hear it because I've made the room pretty much RF type. And I was
Right.
concerned about neighbors and interference. Did you, as we're running out of time, Shawn, is there anything else that you wanted to cover that is crucial to your description of your station and the safety and the RF ground and the rest of it?
So just to reinforce the point you made, I don't believe the feed lines between the transceiver and the linear are good enough for maintaining, let's say, the lowest ground potential between whatever devices you have in your station. You must have a good bonded earth to a bus bar or to a copper pipe or to an RF earth, and never daisy chain run home runs. So each individual, and if you can get those copper plates that go under the transceivers or under the linear that some of the outlets supply, those are fantastic. I think that's one of the best things.
Yeah.
If you can and use them.
You see those in contest stations, and that's an RF, we'll call it an RF rich environment, to say the least, because you might have 5 operators going this at the same time, each transmitter running 1,000, 1,500 watts, and if that guy keys down on 40 meters, you don't want 20 meters going nuts because 7 megahertz times 2. And then the guy who's on 10 meters, the guy on 15 maybe is lucky. So they have to do extensive work to keep it as clean as they can from box to box to box.
Him as well,
Yeah.
yeah.
And I like braid because of its surface area being fairly large, and I want as low an impedance path back to that pipe. And I did use a 3/4 inch pipe because I wanted a large one, and I'll show a couple of pictures of that. And I just clamped each one with a ground clamp, like you'd see on a ground rod. That same clamp goes around the pipe.
Yeah, that's a great setup. And it can be done quite. And again, there's leeway for innovation and thought and custom. However the operator feels, the amateur radio operator wants, feels they can add value or use whatever materials they've got. But there's some good principles, and those are them.
All right. Yeah, thank you. So let's end it here. And it's been a long discussion, and I really appreciate your time. ZS1SBW, W6LG, over.
Yeah, Whiskey 6 Lima Golf, ZS1SBW. I'll see you on the long path, Jim.
Yeah, that's right. Long path rules. All right, thanks.